Welcome to the first course of Six Sigma Blackbelt. We're going to be building on the green belt lessons and reviewing a lot of the green belt and then actually applying it. So this is the first lesson. So what is the value of Six Sigma? What is Six Sigma anyway? Well, it's a disciplined approach, and you develop products and services that are near perfect. Back when I was a kid, we just expect things to break. Now we get upset when the cars break down. This is a strategy for management, and they're using these statistical tools and project management tools to gain breakthrough business metrics, and we'll talk about that later. But these have been around for a long, long time and tried and true. And it's a management by fact, database approach that allows organizations to do the management by fact, which is key to all world-class companies. And the focus is on the customers. Ultimately, it's the customer that decides if our business or organization lives or dies. Just a real brief history of Six Sigma. Basically, it's the history of quality, but the concepts of the tools and stuff, the statistical tools, have been around for a couple hundred years. Early in the 19th century, Gauss started doing this with the normal curve. In the 1980s, Motorola picked this up. Bill Smith, who's a Naval Academy graduate, came up with this yield theory. He basically said it's not just how much fails at the end, but it's how much you're losing in the entire process. He calls that the real throughput yield. Well, he starts talking to another quality guy, Michael Harry, and Michael Harry says, well, look, we need to do this Six Sigma quality. And Six Sigma comes from the statistical term for standard deviation, and they published this thing in 1986. Motorola then coins the word Six Sigma, and they won the Baldrige Award in 1988. Basically, at the time, Motorola leapfrogged the competition in telecommunications as a result of Six Sigma. And the first step is that is define in the DMAIC cycle, define. And this is where you develop a very focused problem statement that describes in measurable terms what the project will deliver. The old adage, what gets measured gets improved, is true. So you want to know exactly what you're going to improve. And you need to put a number on it, be able to measure it. And the process for doing that in Six Sigma is generally done with the project charter. And these things vary quite a bit. I'll show some examples in the reading. So you want to know where you get it started. So what you do is you want to document where you are now and get a baseline. This is the major part of the process. And in this phase, you gather data. And again, data is a plural, right? And you want to focus on the response variable. If you remember the old algebra formula, y would be the response variable of the independent variable of the axis. So you want to see how you're doing overall, get the big picture. And then you start analyzing. And this is where you get the math and the metrics and all the statistics. You look at the top causes behind this. These are the X's. And you dig down and find the root cause. And it's not just a guess. Very mathematical. You can actually see how strongly what you suspect are the root causes relate to the response variable. Very easily. Well, not easily. But that's the whole goal of Six Sigma. I'm going to walk back a little bit. It's not the whole goal of Six Sigma. That's the whole point of the analyze part. Then you say, okay, these are the causes. How do I make sure that I can improve the process? So those things that are causing us problems, headaches, whatever it is, we start looking at. And Six Sigma is all about reducing variability. It doesn't matter if it's a variability in the process, variability in the quality, variability in anything, right? Product or process, you reduce the variability. So we're going to measure that variability, and then we're going to reduce it. I wish I had a nickel for every time I did an improvement project, and then I went back and did the same thing again and again and again. This is the part that gets you to sustain the changes made in the improvement phase. All right? Best controls which require no monitoring. In other words, you change the product or process design so they can't screw it up or change it back. Okay? One of the simplest things I ever did was took away a desk where they're storing all their little secrets and stuff. Very easy. Sneeze said there are some reasons for doing Six Sigma. First thing is bottom line results. When I first started doing this in the 1990s, I wasn't real impressed with it because it just looked like good old-fashioned quality engineering. But what they did is they brought in the financial part. How much is it saving us? And once you start doing finances, then senior management gets interested and get involved. It's very disciplined. Most projects last less than 6 months, and it's management by fact, which is a world-class trait of organizations. World-class companies are database driven. Builds infrastructure. We're talking about cultural infrastructure, intellectual infrastructure. We're talking. This is the kind of stuff that you just can't buy. Customer focus. Ultimately, customer decide if we're good or not. And the mathematics have been around for a couple hundred years. I labeled this slide Six Sigma Gurus, but most of these guys never even heard of Six Sigma. If you look like Philip Crosby, he wrote a book in the 1960s, I think it was, Quality is Free. He showed how much quality problems fail, or poor quality, how much it costs a company. Edward Deming, Joseph Juran, and Walter Sheward actually worked together in Western Electric, and they analyzed variability of processes, and they came up with SPC. Deming and Juran actually went over to Japan and taught this to the Japanese. The Japanese applied it to get their quality up. In fact, the highest quality award in Japan is still called the Deming Prize, named after an American. Feigenbaum, he did the TQM. Ishikawa, he does the root cause analysis. Taguchi, he came out with the orthogonal arrays that we use in our DOE, or design of experiments. And of course, he talked about Bill Smith and Michael Harry at Motorola.
James Womack, MIT professor, and Daniel Jones, who was in the UK, well, they got together and they wrote a book, I think it was in 1980, The Machine That Changed the World. And basically, they explained all about lean. Very influential book. As a side note, the person that taught me lean manufacturing, the Toyota production system in the 90s, was a guy named Dave LaHote, and he actually worked for the Institute. Brilliant ideas. When I first saw it, it was just revolutionary. Womack and Jones, United States and England, brought lean concepts to the forefront. Comparison between Six Sigma and lean. Yes, it's kind of obvious the differences. What I like to do is integrate the two. So a lot of people start a lean project. Oh, okay, we're going to reduce, I don't know, such and such an operation. And what they don't do is they don't put the metrics to it. So Six Sigma puts the better metrics on it. Yeah, did you save it? Did it actually save our costs and stuff like that? And did you reduce the variation? Or did what you do change the amount of variation in the product? Did you fix one problem in a system only to make another problem somewhere else? So they go very nicely together. Again, I can't tell you how many lean claims I've seen in factories have been debunked when you put the metrics of Six Sigma or analysis of Six Sigma on it. They fit together very nicely. Lean Six Sigma. Okay, we got the tools. We got the define, measure, analyze, improve, and control. DMAIC, and what tools are used under each one of these phases. I'm going to share this slide as a separate handout in the course. We'll also talk plenty about every one of these tools. I say every one, most of them. Yeah, we'll have plenty of this in the course. I first saw Six Sigma and they said, hey, you're going to be a black belt or whatever. I said, I don't see much difference between this and basically my stats class in college, or even the quality engineer or quality manager. The big thing that they did in Motorola that really set this off is profitability. They actually put a number built on Crosby's ideas of how Six Sigma can save you money, and the variation is costing you money. So examples, I mean, they're kind of obvious. Cost savings, customer satisfaction. If you got a mad customer, you're going to lose money. How your process variations going to cost you money. How problems, stoppages of the system cost you money. Your transport costs, all that location, and also location where you do certain things. How much you move things around. Design problems, supplier issues. All of that, if it varies and you have problems with it, is cost and money. And that's what Six Sigma focuses on, is using the analytic tools to save money or make money. Yeah, we're going to be talking about systems. And the key thing here, again, this is the middle part of the SIPOC model. You got to know how everything integrates within each other. So, what about the project organization or the objectives? Um, how does that influence the inputs or the outputs, right? And do you have a feedback mechanism? It's amazing how many people do things totally blind. They don't know what the result of their actions, what happens downstream as a result of their actions. You need that feedback loop. But this is a simple system, very simple system. You have to understand the relationship between the inputs, the what's going on, the processes, and the outputs. In the 80s, Ronald Reagan was president and had his interior secretary, Malcolm Baldrige. And he says, why are the Japanese beating us? What are they doing that we don't do? So Baldrige got a bunch of people and he sent them out all over the world. They read Shinko's book and he said, well, there are seven things. Leadership, uh, good companies have good leadership, visionary leadership. They do strategic planning. They focus on the customer. They take care of their workforce, their employees. They got good management of their processes, and they look at the results. And all of this is underlaid with the measurement, analysis, and knowledge base. In other words, they manage by fact, and they just don't wing it. Baldridge died in a rodeo accident, uh, and then they created the Baldridge Award um, after him. But this is known as the Baldrige hamburger. It shows how the six, basically the processes, you got the planning, and then you got the results part of it. But it's all underlined with facts and data. Management by facts. Good organizations manage by fact. Yeah, this is a list of everything that happens within a business. Well, I said businesses, but organizations. Um, what they must do, right? So they can go down. They got resources, engineering, and the rest of it that follows. Should be very obvious why business have to do these. They have to do each one of them well. That's the trick. Each one of these has to be done well. Otherwise, an organization will crash and burn. That's the whole point of this. It's all if one fails, it all fails. When I do some consulting, back in the day when I was really hot and heavy into it, we did a lot of times I tell the companies do a SWOT analysis: strength, weakness, opportunities, and threats. And then I'd come in and take a look at this, what they had. A lot of times it's just fiction, right? So I'd go in and say, what are your strengths? And they'd tell me, and it's just their perception, right? Uh, if you actually start putting a metric to it and benchmarking, well, maybe they're not, you know. I'll use my institution as an example. They want to know the perception of different groups, right? So they asked for volunteers to take the test or the survey. We had about, I don't know, 10% return. Uh, and they had to put their name on it too, right? Oh man, we were just flying high. We were the greatest college since sliced bread. However, if you took that same survey and took it to a group, in this case we were talking about high school kids, and said, what do you think of A and C? And you force them to answer, not put their name on it, you get a different answer. Um, SWOTs are good, but don't make it fiction. It's got to be based in reality. And if you hire a consultant like me, I'm going to come in. I'm going to start saying, put some numbers on it. And I'll start questioning everything. You need that, right? You need a jerk to come in and just tell you, hey, you're not the greatest thing since sliced bread. You're kidding yourself, right? Uh, Motorola thought they were the best cell phone company in the world, and well, Ericsson came in. Now you got Apple uh, and other companies beating them right now. So be careful with this one.